Bismillahirrahmanirrahim. In this session, we will discuss magnifying glass from the topic of lights under O-level physics of written by, this book is written by Tom Duncan and Heather Kennett, published by Hodder's Education. In a magnifying glass, the apparent size of an object depends on its actual size and on its distance from the eyes. So the actual size and the distance from the eye. So the slipper on the railway tracks are all the same length, but those nearby seems longer. This is because they enclose a larger angle at our eyes than more distant ones. So the nearer object looks larger in size and the far distance object looks smaller as compared to. So because their images on the retina is larger, so making them appear bigger. So the nearby object makes a larger image on our retina. So a converging lens gives an enlarged, that's why this is one of the reasons that a converging lens gives an enlarged upright virtual image of an object placed between the lens and its focus. So this is very important, and this is shown in figure 3.240A. So this is 3.2.40A, and here we have this object and we are focusing it here, and this is our converging lens. So from this focus to we are seeing this object, and since the object is between the center of the lens to the focal length, so on this principal focus line we have object between the optical center and the focal length focus. So within the focal length object is placed and it gives a larger image here, a larger in size. This is the virtual image. If we see this object without a lens, then it will make this kind of thing. It will mix this. So this object without a lens, it will make an angle alpha. So this alpha is smaller in size as compared to this beta. This alpha is smaller. So we can see the fatter, more curved a converging lens is, the shorter its focal length. If the lens is fatter, then its focal length will be smaller, shorter, and more it magnifies. Too much curvature, however, distort the image. So this is also, keep in mind that if the curvature is too much, then the image will be distorted. So it acts as a magnifying glass, and the angle beta made at the eye by the image formed at the near point is greater than the angle alpha. This beta angle is greater than this alpha. When it is viewed directly at the near point without the magnifying glass. If the object is seen by the without magnifying glass, we are seeing it directly, object with our eyes. Here the object is being seen through the lens and the image is formed here. So this is magnification. A linear magnification of an image is defined as the ratio of the image length here we have this image length and the object length. So the ratio of image length to object length is called linear magnification. So linear magnification is the ratio of the image length to the object length. Through spectacles, so this is our eye, and we have an object here, and through this retina we have this an inverted image. Since it is very far away, So the adult eye can focus object comfortably from about 25 centimeters, the near point to the infinity, the far point. From near point to the far point, so 25 centimeters is sufficient for a normal human being. The nearer point may be less than 25 centimeter if it get further away with ages. So this value may change with the age and other medical reasons. Short sight. A short-sighted person sees near object clearly. Short-sighted person sees near objects clearly, but distance object appeared blurred. So here we have a distance object, but it is blurred. The object of a distance, the image of a distance object is formed in front of the retina because the eyeball is too long. The eyeball is too long, or because the eye lens cannot meet the thin enough. The eye lens cannot be made thin enough. Figure 3.242a. This one. The problem is corrected by diverging spectacles. So we place a diverging spectacles in front of this, so it will slightly diverge it and it converge at this place. So image will be formed here. So instead of this place, the image will be formed here after placing this thin lens or diverging lens. So this diverging lens, so for short-sighted persons, we use this because short-sighted person can see near object easily, but far object is difficult to see. So long sight, a long-sighted person sees distance object clearly, but close objects appear blurred. The image of a near object is focused behind the retina, but the near object focused behind the retina. So here the image is formed here. So for this we use a converging lens here, so this image will be formed here like this. If you place a converging lens or a convex lens, so this image will be formed at the retina. So near object focus behind the retina because the eyeball is too short, or because the lens cannot meet thick enough. So as a result, we place a converging spectacle lens or contact lens, correct the problem which is here. In the next session, we will discuss test yourself.